exact differential equation, polar form. Previously, we have solved the problems on Cartesian form, that is m dx plus n dy equal to 0. Dou m by dou y and dou n by dou x is exact condition. Now, this is polar form means r and theta terms. They contain r and theta terms. They actually, what is the general form of the exact differential equation in polar form? The same thing, the previously m dx plus n dy equal to 0. Now, m d theta plus n dr equal to 0. This is exact differential. If you want to say this is exact differential equation, then you have to check exact condition. Dou m by dou r equal to dou n by dou theta, and the solution is integral m d theta plus integral n dr. While integrating with respect to theta, treat r terms as constants and integrate those terms which are free from theta when integrating with respect to r. This is nothing but exact integration rule. Let me solve one problem. First problem, solve the differential equation r plus sin theta minus cos theta into dr plus r into sin theta plus cos theta d theta equal to 0. The first one, rewrite that equation into the general form, r into sin theta plus cos theta d theta plus r plus sin theta minus cos theta dr, means I wrote in the form of m d theta plus n dr equal to 0. Now, comparing with that general form, then I got m equal to r sin theta plus cos theta and n equal to r plus sin theta minus cos theta. Dou m by dou r means differentiation, partial differentiation with respect to r, sin theta plus cos theta, and dou n by dou theta equal to, this is r, is the differentiation of r is with respect to theta 0, differentiation of sin theta is cos theta, again differentiation of cos theta is minus sin theta. Before the term we have minus symbol, minus into minus it becomes plus, cos theta plus sin theta. Therefore, dou n by dou theta equal to sin theta plus cos theta. Dou m by dou r equal to dou n by dou theta, means this function satisfied the exact condition. Then the equation 1 is called exact differential equation, means you solve that differential equation by exact method. According to exact method, the general solution of the differential equation is integral m d theta plus integral n dr equal to c. Now I am substituting m and n values here. Integral r sin theta plus cos theta d theta plus integral r plus sin theta minus cos theta dr equal to c. Now, integration with respect to theta means r terms as constant. I am writing r outside. Integration of cos theta, sin theta is minus cos theta. Integration of cos theta is sin theta. Then again it is sin theta minus cos theta. It is not free from r. Therefore, instead of that one, we are writing integration with respect to r means that is 0. Then r dr is r square by 2 plus c. Then this is the final answer of the exact differential equation. And sometimes exact differential equation. Now, previously in Cartesian form, I explained you m dx plus n dy equal to 0. That is exact differential equation. Exact condition is dou m by dou y equal to dou n by dou x. General solution is integral m dx plus integral n dy equal to c. Means integration with respect to x is y terms constant and integrate those terms which are free from x while integrating with respect to y. Suppose dou m by dou y not equal to dou n by dou x, then that is not exact differential equation. If it is dou m by dou y not equal to dou n by dou x, then you can, that is nothing but non-exact differential equation. If you have non-exact differential equation, you convert non-exact to exact differential equation by multiplying with suitable factor, by multiplying with suitable extra factor. Then that suitable factor is called integrating factor. Means when should I use integrating factor? Suppose dou m by dou y not equal to dou n by dou x, then you can use integrating factor. Then after applying integrating factor, then that non-exact differential equation becomes as exact differential equation. Already I explained 4 types of integrating factors. Using those 4 integrating factors, again we can solve the exact integrating differential equation by the general method.